Question 1. State the 5 steps of the statistical process and provide a brief description for each step. Okay, we're going to walk through this one as if we were going through a real study, a real experimental study. Okay, so let's pretend we would like to collect information on the body temperature of students here at BYU Idaho. Okay, so the first one is design the study. Okay, so first we got to start out with a research question. So maybe our research question is simply, what is the average body temperature of students here at BYU Idaho? Okay, now also something that we need to do during the design of the study is what we need to do in order to answer the research question. Okay, another good question is what is the whole population? Okay, so for this example, the population is the students of BYU Idaho. We'll pick out a select few, and then we'll make inferences about the whole population of BYU Idaho. Okay, and then what kind of data needs to be collected? Well, if we're going to be interested in body temperature, then we need thermometers that can measure the temperature of students. Okay? Part 2 is collect the data. In this step, we discuss how we're going to pick which students which students we are going to take the temperature of. So the first step is to decide what type of sample we're going to collect. Is it going to be a cluster or a systematic or a simple random sample? And that's something that we can talk about in question 2 of this assignment, is how to differentiate between those different types. But then another point in step 2 is that in collecting the data is that we actually go out and we collect it. Okay? Part 3 says describe the data. Okay? Now after we've collected all of the data, we describe what we saw. So we give statistical summaries such as means and medians, and you'll learn about things called standard deviations and p-values, all of those numbers that you get that represent the data that you collected. Also any graphs you'll do in describe the data. Okay, part 4 says make inferences. Now this is where we take all of that information that we gathered about the body temperature of, say, maybe the 100 students that we sampled, and we project it upon the whole population of students here at BYU Idaho. So if we found that the average temperature in the students was maybe 97.2, then we can say, and we'll talk about how confident we can be in this number later in the semester, but we can say, we're confident that the population of students at BYU Idaho, their temperature is 97 degrees. Okay, so it's that making inferences is taking the sample that you collected and projecting it on your whole population. Step 5 says take action. Now taking action is when we use the information that we got and we try and apply what we learned. So for example, maybe if on our body temperature we found that everybody's temperature was 99 degrees, then that would be something to be concerned about. Maybe there's a sickness that's going around, and so we could give that information to the health center so that they could figure out what to do in order to get everybody into a healthier position. Okay? So the take action is just what you do with the information you gathered. Why did you even do it to begin with? Question 2. Match the following statistical terms with their appropriate definition. Okay, the first one is simple random sample, which is C, option C, computer generated or drawn from a hat. Okay, so this is the most basic one, the one where it's just every single person has an equal opportunity. If we're still talking about the body temperature of students, maybe we got a list of all of the students in the whole campus, and we assigned every student a number, and then we computer generated a few numbers, and we picked out those numbers and we sampled those students. Okay, so that would be simple random sample. Stratified is letter A, which our subjects are in groups according to some similarity or characteristic. Okay, so for example, maybe we wanted to make sure that we got in our sample some freshmen, some sophomores, some juniors, and some seniors. So so we separated those on the list. Okay, and we picked out maybe 25 from each school class. Okay, or maybe we wanted to make sure that we got the same amount of boys as girls. or at least a good number of boys and a good number of girls. So we split them up and then chose from one and the other. Okay, so stratified is you break it into groups, and in each group they have something in common. It's kind of like you could think of it as maybe divide them into clubs, where everyone has the same interest in the club, or some characteristics that are the same, and then we sampled a few from every group. The next one is systematic, which is letter B, and that is the subjects are put in some kind of sequential order. So this maybe the students on campus are put into a list in alphabetical. Okay, and then we randomly choose a number between 1 and 100. Say we chose 87, and that means we sample every 87th student. Okay, so we sample student number 87, and then we sample student 170, or whatever 87 times 2 is, and we go all the way down the list, and we select that student, the 87th student. Part D says cluster sampling, which is D. Subjects are put into groups that hopefully represent the whole population. Okay, so this is the second sampling strategy where we divide them into groups. But this time, the groups, they're not like clubs, meaning the groups don't have anything in common. There's nothing special about this group that makes it different than this other group. So instead of boys and girls, or freshman and sophomore, or blonde hair or brown hair, what cluster does is cluster says, well, maybe let's take the library and let's take the west half of the library and compare it to the east half of the library. Or we'll split it into those two groups. There's nothing really special about the east side versus the west side of the library. There's all sorts of students, both genders, all classes, all hair colors. Okay, so there's nothing specific. And then what we do is we sample everybody in one side. Okay, so we'll sample the entire west side of the library. That is cluster. Cluster is when you sample everyone in one group, as opposed to stratified, where you divide them into groups and sample a little bit of everybody. Okay, and that'll come along. Make sure you can think that through and make sense of that in your mind. Question 3, provide a brief description for each of the following terms. Okay, there are two main types of studies. The first is an experimental study. The second is observational. Okay, there's a few major differences between the two. In an experimental study, the researchers, or those that are performing the study, influence the subjects, or they influence the people that they're studying, or the situation that they are studying. So for example, let's talk about health. In medicine, if researchers have developed, or scientists have developed some new medicine, then they do an experimental study where they bring in a group of people, they divide the group into two, they give one group a sugar pill, and they give another group the pill that has the new medicine in it. Okay, so you see they are influencing the health of the subjects, of all the people involved in the study. That's an experimental study. Now, an observational study, one in the health field, might be, let's take the age of death of Utah, collected from hospitals in Utah, and let's compare that to the age of death in hospitals in Idaho. Okay, so the researchers are having no influence on the health of the beings. They're just looking to see which one is healthier, or which one lives longer. That would be an observational, because they're not influencing the people that they're studying. Okay, so that's the difference between experiment and observational. The next is the treatment. Now the treatment is involved in the experimental, and that's what the researchers give to the subjects. So the sugar pill and then the medicine. Okay, so the medicine would be that treatment. It's what they get and what's observed. The response variable is the variable that changes or responds to the treatment. Okay, so these people that receive the pill that had the medicine in it, the variable is what changes due to that pill. Do they get healthier? The subjects, of course, then are just those people that are in the study. The subjects are those that are that we are observing or that we are experimenting upon. Question 4, to find the null and alternative hypotheses. Okay, so the null hypothesis is the foundational assumption about the population or the status quo. Okay, so if we think about body temperature again, the null hypothesis is what's just generally accepted, okay, which is 96.8 degrees is kind of the general textbook. This is what a healthy, normal person's body temperature should be. Okay, but the alternative hypothesis is basically the opposite. What if it's not 96.8? Maybe up here at BYU Idaho, you want to do a study on the body temperature of students because you think the body temperature is going to be colder because Rexburg's so cold. And so your null hypothesis would still be 96.8, but your alternative might be less than 96.8. Okay? And so you think that the body temperature has actually gone down. And then your study would help you find out if that was true or not. So the null is what is generally accepted as true. The alternative is what it might be, or what you think it is, or in other words, it's what is true if the null hypothesis is rejected. Question 5, define the p-value. Okay, so the p-value is a probability. It's a probability that the results of your study that will be observed that is as extreme or more extreme than the information observed, assuming the null hypothesis is true. Okay, so let's break that definition down just a little bit. So if we go back to the body temperature, if we find, it's basically the probability that our results just happened by chance. So if we collected 100 students' body temperatures and we found that the average body temperature of the students that we collected was 100 degrees, then our p-value would be what is the probability that the average body temperature on campus is 96.8 degrees and we just happen to pick out randomly the 100 sick people on campus. Okay, so that probability is a number between 0 and 1 that says what are the chances that our results happened even though the null was true. So we got an average of 100 degrees even though the null hypothesis was true, meaning it was 96.8 degrees. Okay, now the p-value is a very important number in statistics that's used all the time, one of the most important of the whole semester. So don't worry too much right now if you don't understand it completely, but as you start to use it, make sure you always take a step back and ask yourself, okay, what does the p-value mean? What does this mean for the whole population? A medical student researches the prevalence of aspirin usage by questioning all of the patients who enter her clinic for treatment. Okay, so this is a convenience sampling because she just took the people that randomly showed up at the clinic in that one single day. Okay, so it just was convenient because that's what was happening and there was no sense of random. It was only doing one clinic, probably only one day, and so it was just those that were coming in. So there was no sense of random. It was just those people that came in that day. That's a convenient sample. B, the Colorado Department of Health obtains an alphabetical list of 2 million adult Colorado residents and constructs a pool of survey subjects by selecting every 1,000th name on the list after randomly choosing one person from the first 1,000 on the list. Okay, so this is a systematic sampling. Okay, it's a perfect example of systematic where you line up all of your subjects and you assign them a number and then you choose a random person from the first 1,000 and then every 1,000th person you select as well. Okay, so systematic means you pick one and then you just kind of leapfrog picking that every interval, that person. C, in a Gallup poll of 1,059 adults, the interview subjects were selected by using a computer to randomly generate the telephone numbers that were called. Okay, this is a simple random, classic simple random where you just use a computer-generated software to generate the possible telephone numbers. D, a dietitian has partitioned people into age categories of under 18, 18 to 49, 50 to 69, and over 69. She is surveying a simple random sample of 200 members of each category. Okay, so this is stratified. Now the key to stratified is that we've divided them into groups, and within each group, the people have something in common. In this case, it's age. Okay, so we have the 18-year-olds, the 30-year-olds, the 60-year-olds, and the above 69-year-olds. Okay, and then we took a few from each. That is stratified. E, a Johns Hopkins University researcher surveys all cardiac patients in each of 30 randomly selected hospitals. Okay, so this is a cluster sampling. Okay, it's cluster because we've divided them into groups. Okay, maybe all the hospitals in the entire United States, and then we chose a few of the groups and we surveyed everybody in those groups. Okay, so we sampled all the cardiac patients in each hospital. That's a cluster sample. Question 7. The American Medical Association wanted to determine general patient satisfaction with the patient's primary care physician. Determine the type of sampling method used in the following scenarios. A. They take a simple random sample of doctors and then sample all of the patients that the doctor works with. Okay, so that would be cluster because they take a sample of the doctors and they sample all the patients. So they divide them into groups and then they sample all of the patients of certain doctors. Okay, so groups, there's no difference between all of the groups, but they choose one group and sample everybody from that group. That's cluster. B, they put all of the residents' names in a computer and use a random number generator to get a sample of 100 patients. Okay, it's a very easy, simple random sample, just computer generated. Everybody had the same chance of getting selected. C, they divide the residents up by gender and then do a simple random sample of residents within each gender. Okay, so the key there is within each gender because we're going to divide them into groups and then we're going to take some from this group and some from this group. So that is stratified when the groups have something in common, in this case gender, and then some are taken from both. D, they randomly pick key intersections in the city and then picking every 5th person that walks by after randomly picking one of the first 5 people to be in the sample. Again, this is systematic sampling. Systematic because we choose a person and then at every interval we choose that person again. Okay? So we choose the 5th person, the 10th person, the 15th person, the 20th person. Question 8. Determine for each scenario whether it is an observational study or an experimental design. Okay. The Center for Disease Control obtains current flu data by randomly polling 300 men and 300 women. Okay, so they're just curious how many people have the flu out there. So they pick 300 men, 300 women, and they test them to see if they've got the flu. That is an observational survey because they did nothing to influence their health. They were just observing their health. Part B, you plan to conduct an experiment to test the effectiveness of sleepies, a new drug. Blah, 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 blah. Okay, this is an experimental design. It's an experimental design because the patients are receiving some kind of treatment by the researchers. Or in other words, the researchers are influencing the health of the patients, in this case, the subjects. So the response variable is the hours of sleep that the people get, because when they're going to divide them into 2 groups, they're going to give some a sugar pill, they're going to give some sleepies, and then they're going to test. They're going to see how many hours did they sleep. So the response variable, remember, is what you're determining, how you're measuring whether the experiment worked or whether the experiment did not work. The treatment was the sleepies and the placebo. The treatment is what you're giving the patients, and the subjects were the 1,000 patients that were suffering from insomnia. Question 9. A. Is this a designed experiment or an observational experiment? Okay, this is definitely a designed experiment because the subjects are receiving some kind of treatment. Okay, in this case, the researchers are influencing the health of the subjects by giving them the creams that they're testing. B. What are the subjects? The subjects are the 224 patients that were diagnosed with the skin irritation. Okay, so it's the people that they're going to give the medicines to test them, that 224 people group. C, what is the response variable in the experiment? So the response variable is how you're going to measure the success of the ointment or the cream. Okay, so it's probably some form, they're going to measure the amount of skin irritation by maybe by area or by color. That would be up to them. But it's how they're going to determine whether the cream worked or not. D, what are the treatments? The treatments are the 0.5% cream, the 1% cream, and then the placebo. Okay, so remember, the treatments are what you give the subjects in your study.